The Druk White Lotus School is located in the village of Shey in the Ladakh region of India, which is close to the Himalayas. The school itself is attended by over 750 children, ranging in age from nursery school right through to 18 years old. Now, when we think of India, we might think of megacities like Delhi, Mumbai or Bangalore, which are home to tens of millions of people. However, the village of Shey, with a population of just over 2,000, couldn't be further removed from those places. And indeed, the Ladakh region, which has an area greater than all of Scotland, has only a population of just over 250,000 people. So it's a very sparsely populated area, and it's also very remote, and at an altitude of 3,500 metres above sea level, it experiences extreme temperatures through the year. So the project was inspired by local spiritual leader, His Holiness Drukpa, and it was delivered through the Drukpa Trust. The Drukpa Trust approached civil engineers to design and build the school, and they responded to that and came up with designs and construction methodologies to deliver the school project. Now, the project was really needed by the people of Ladakh because they wanted a school that would promote the heritage and culture based on Tibetan Buddhism, but also equip future generations with the skills to meet the challenges of the 21st century. So when the civil engineers were designing the scheme in such a remote location, they probably had four major concerns to deal with, four major challenges. Firstly, the Ladakh region is a seismic area. As recently as 2017, the region was hit by an earthquake with a magnitude of 5.4 on the Richter scale. So that was something that the civil engineers involved in the scheme had to take into account. Secondly, the region is very isolated, and you have to think about what materials and skills are available to actually deliver the construction phase. So in the UK, for example, we would take for granted things like steel or concrete construction because the materials are readily available and the skills and trades are there to support that and deliver that. But that wasn't the case here, and so the civil engineers involved in the scheme had to make full use of the materials locally and also the skills and local building methods that were available. Thirdly, the Ladakh region has very limited infrastructure, particularly in regards to power and things like water supplies. So the school would have to be self-sufficient. So that was a major challenge that the civil engineers had to overcome. And finally, because the region is so remote, it's very inaccessible and can only really be accessed for 6 months of the year. And within that 6-month period, there's probably only 3 or 4 months where you could actually build anything. So the civil engineers had to create a design which maximised on-site efficiency as much as possible. Well, as civil engineers, we need to look beyond the fact that this is just a school building. We're trying to create high-quality learning environments which will benefit every child that goes there. Civil engineers would also have to be aware that this school was likely to be a focal point for the area, something that the local community would take real pride in. So again, that would need to be reflected in the final design. So to achieve that, the civil engineers came up with some really innovative ideas. Firstly, they orientated the building 30 degrees east of due south and maximised the east-west access of the building. And that was really to expose as much of the building as possible to the early morning sun, which would get the real benefit of the solar energy. And that solar energy was then stored in trome walls that were incorporated into the construction, and those walls would then release the heat through the day. Secondly, the building made full use of local materials and local skills. So for example, the outer walls were constructed with granite that was found on site and nearby, and the roof itself was made using soil found on the site, as well as willow found locally at the monastery plantation. And the inner walls were created using mud brick that was made in Shey. And finally, one of the innovative things they used was photovoltaic panels. So because the school is at such a high altitude at over 3,500 metres above sea level, it's well placed to really benefit from solar energy, and the design team made full use of that. But not only did they do that, they also positioned some of the photovoltaic panels so that they would actually provide shade for the school during extreme heat wave conditions. So again, a very innovative idea. So in addition to powering the school, it also provided a benefit in terms of shading the school. Well, the Druk White Lotus School not only benefits current generations of children, but really benefits the entire community, because each child that goes to the school is going to learn about their culture and heritage, but also learn new skills that will equip them for careers outside the region and new technology. And I think to achieve this, the civil engineers involved have taken the best of local materials and local skills and married that with their sort of modern design techniques and technologies. And I think there's something very elegant about that, because that really reflects the ambitions that the Ladakh people had for the school itself. So it really is an incredible project. So whilst I haven't worked as far afield as the Druk White Lotus School, I have worked on a wide variety of projects, including bridges, ports and buildings that have benefited the communities here in the UK. And often these projects are created to solve a problem. And when you see the project come to fruition and actually then have a real positive impact on those communities, as a civil engineer, I take great pride in that.